All right, let's dive in. Today, we are going to get into the real architecture of Java. I'm talking about how you can build code that's not just clean and organized, but also, and this is so important, how you can build in the right kinds of locks and walls to protect it from, accidental misuse.
So, I want you to think about the code you're writing right now. Be honest, is it kind of like a messy shed? Tools everywhere, you can't find anything, and it feels like one wrong move and the whole thing could just collapse? Or is it more like a grand mansion? You've got clear rooms, dedicated hallways, and of course, locks on the important doors. See that difference right there? That's all about architecture. And the good news is, Java gives us all the tools we need to be fantastic architects.
So throughout this explainer, we're going to stick with this idea of a code mansion. It's a really great way to visualize how Java uses two key concepts. We're talking packages and access modifiers to help us build really solid, maintainable software.
All right, so first things first. Before you can even think about building that mansion, you need to pick a spot, right? A plot of land in a good neighborhood. Well, in Java, those neighborhoods, we call them packages. So what is a package, really? Well, it's basically a folder. It's a namespace that groups together all your related code. Think of it like the unique street address for your mansion. It tells the entire Java world exactly where your house class lives, so it doesn't get mixed up with some other house class in a completely different neighborhood.
Okay, so why should you even bother with packages? What's the point? Well, they do three really critical things for us. First, and most obviously, they organize our code into neat, logical groups. Second, they stop us from running into naming problems. My door class won't clash with your door class because they live in different packages. And third, and this is a big one, they create the very first line of defense, the first boundary, for controlling who gets to access the code you've written.
Now let's say your mansion needs something special, maybe some fancy custom windows that are made by a craftsman in another neighborhood. How do you get them? Well, that's where the import statement comes in. It's literally your invitation. It lets your code reach out and use the public classes from other packages.
And hey, there's also this neat little shortcut called a static import. This is like, your neighbor has this one amazing tool, maybe a specific wrench. Instead of having to say, I'm using the wrench from Bob's house over and over again, you can just say, wrench. A static import lets you do exactly that. Use static members from another class without constantly typing out the class name first. Super handy.
Okay, so our mansion is built, and it's in a nice neighborhood. Now it's time to go inside. We're talking about the rooms, the valuables, the inner workings. And this brings us to maybe the most important question for any architect. Who gets a key?
In the world of Java, our keys have a name: access modifiers. These are just keywords, little labels we put in front of our classes, our variables, our methods, to spell out exactly who has permission to see them and use them. This is, without a doubt, the core of our mansion's security system.
So Java gives us 4 different kinds of keys to hand out. Each one unlocks a different level of access. Let's go through them one by one, starting with the most open and working our way down to the most restrictive.
First up, we've got public. This is the front door key. The welcome mat is out. Anybody from any package, anywhere in your project, can just walk right in and use it. You use this for the parts of your code you want the whole world to interact with, your main APIs. Next up is protected. Let's call this one the family key. Now, this key does 2 things. It opens doors for anyone else living in the same package, but, and this is its special power, it also works for subclasses, direct descendants, even if they live in a completely different neighborhood, package. This is how you create things that are meant to be extended by other developers.
All right, now what happens if you don't type any modifier? No public, no private, just nothing. That's what we call default, or package private access. Think of this as the Houseguest Key. Anyone who's inside the same package, the same house, can use it. But the second you step outside that package, that door is locked. This is perfect for all those helper classes and methods that you need internally, but you really don't want to expose to the outside world.
And finally, we get to the highest level of security, private. This isn't just a locked door. This is a locked diary inside a safe. The only code that can access something marked private is other code inside that very same class. That's it. Not other classes in the package, not subclasses, nobody. This is for the secret internal machinery of your class that no one else should ever touch directly.
Okay, let's do a quick recap. We've got public, the front door key, wide open for everyone. Then we have protected, the family key,
which is for anyone in the same package plus any subclasses, no matter where they are. Then there's default, the Houseguest key, which only works if you're inside the same package. And finally, private, the locked diary, which is only accessible from inside the class itself. You can see how the access gets tighter and tighter as we go down the list.
But wait a second. Let's zoom in on that protected key for a minute, because it's definitely the trickiest one. How exactly does a family member, a subclass, that lives in a whole other neighborhood get access to the protected rooms in its parents' mansion? How does that work?
The secret is inheritance. Simple as that. When one class extends another, it creates that official family tie. And that bond is what gives the subclass its own copy of the family key, letting it access all the protected stuff from its parent, no matter how far away it lives.
So, we've talked about neighborhoods, mansions, rooms, and a whole bunch of different keys. You might be wondering, why all the fuss? Why is all this architectural stuff so important? Well, it all boils down to one of the most important principles in all of software design.
And that principle is encapsulation. It's a fancy word for a simple idea. Hide how things work on the inside. You bundle your data and the code that works on that data together, and then you tightly control access to it. That's what access modifiers let us do. I mean, think about it. You don't let a house guest start rewiring your walls, right? No, you just give them access to the light switch. That is encapsulation. And when you get this right, you get 3 huge wins. First, security. You're protecting your important data from being messed with. Second, collaboration. Your teammates can use your code without having to understand every messy little detail inside, and more importantly, without being able to accidentally break it. And finally, maintainability. Because you've hidden the internal details, you can go in and change them, improve them, refactor them, and as long as you don't change the public parts, nobody else's code breaks. That's a game changer.
So there you have it. You've got the blueprints for organizing your code, and you have all the different keys for controlling access. The only real question left is, what are you going to build? Every single time you write a class, you're making a choice. Is it going to be another messy, insecure shed, or a well-designed, maintainable, and secure mansion? The kind of architect you choose to be? Well, that's entirely up to you.